Car stops at two sets of traffic lights. Figure 2 shows this. So the car is stopped at one set of traffic lights here, speeds up, hits the maximum velocity, then slows down, stops at the second set. And we're told that the speed is modeled by this equation here, where t seconds is the time after the car leaves the first set of traffic lights. So according to the model, find the value of capital T. So what I'm going to do is set the velocity equal to 0. That's going to be when it stopped. 10 minus 0.4 t multiplied by ln t plus 1 is equal to 0. So here we either have that ln, these are multiplied together, so it's either that ln t plus 1 is equal to 0, or 10 minus 0.4 t is equal to 0. The first one actually gives us t is equal to 0, so okay, that's actually that bit there. The second one is going to be 0.4 t equals 10, so we can do 10 divided by 0.4 to give us the time when it stops at the second set, so 25. I'm just going to write down t, capital T then is 25. Show that the maximum speed of the car occurs when this equation is satisfied. So I'm going to need to differentiate to find the turning point. dv, actually, yeah, no, dv by dt. And I'm going to use the product rule here. We've got a product of functions. I know I've got a v in there, which is a little bit awkward because normally we call this u and this v. So I have to call it w. Then u dash, which is u differentiated, is going to be minus 0.4, and w dash is going to be 1 over t plus 1. So then dv by dt is going to be u dash w plus u w dash, which is minus 0.4 ln t plus 1 plus 10 minus 0.4 t times 1 over t plus 1. So I can just divide straight away by t plus 1. And that's going to equal 0 for any stationary points. And we need to rearrange this now to get the equation given. So I think the first thing I'm going to do is just get it as 0.4 ln t plus 1 equal to 10 minus 0.4 t over t plus 1. I need to make t the subject, but leaving it, not quite making t the subject, having t, like these t's kind of together, and then just with the ln t plus 1. I'm going to multiply through by t plus 1. So 0.4 t plus 1 times ln t plus 1 is going to equal 10 minus 0.4 t. Divide through by 0.4 now, just get rid of that. There's no fractions in the answer. 10 divided by 0.4, did we do that a minute ago? Yeah, it was 25. So we're going to get 25 minus t. Okay, that's much better. Then I'm going to expand the bracket on the right and add the t. So it'll be t plus t ln t plus 1 is equal to 25 minus ln t plus 1. I've just rearranged it as I've gone there. And I can now factorize out the t. It's not looking quite right yet, but look, just be aware of this. There's a minus 1, but it's sort of not within the fraction. So we're going to have to just mess about with it a little bit. And there's a 26 in the answer, whereas we've only got 25. So why don't I just write it as 26 and then minus ln t plus 1 plus 1 in a bracket. The reason I've done that is because I know in my answer I want 26, and I'm going to now divide through by 1 plus ln t plus 1, and it's going to cancel. So t is going to be 26 over 1 plus ln t plus 1 minus ln t plus 1 over 1 plus ln t plus 1. This is just going to cancel. That's going to give me the answer. Okay, so that's probably the trickiest bit, getting this bit sorted at the end. But we're there. This just leaves us the last part, which is to use an iterative formula to solve this equation that we've just derived actually. See, we've got a ln of t and a t. We can't undo logs or anything for this sort of thing. We need to solve it numerically. And this is actually called fixed point iteration. I'm not going to go into detail on it here, but have a look into it if you're interested. I've done like lots of other videos where I talk about it. But here we're just going to substitute it in, like, because I don't want to overcomplicate the proceedings. Okay, so we put t equals 7 into here, and we see what we get out, basically. So t1 equals 7. I'm going to write down what t2 is. I know it asks us for t3, but I think it's good to just show you the steps. I know it doesn't ask for it. So 7 equals, gets that 7 into my answer button. Then 26 divided by 1 plus ln answer plus 1 minus 1 will give me a new value of t, which I can then find by pressing equals again. So 7.4430. And let's press equals again to give us t3, 7.2978. Then to 3 decimal places, that's going to be 7.298. Part 2 is then to find the actual time. We just have to keep going. It's not, it's no more complicated than just pressing equals a lot of times until it converges. It's converged. 7.3328. Actually, this was capital T, wasn't it? It doesn't say how many, how much, how to round it here, so I'm just going to go with 3 significant figures. 7.33. Well done.